Okay, I know these things go together somehow, but this doesn't seem like that's going to fit in that at all. Maybe if I push harder. Hey guys, this is Jim, WT1W, and you're watching FEPLabs Radio. Thanks for stopping by. So in this video, I want to do M17. I have an M17 module board that was sent to me by a viewer, Doc Brad, and we used these on Nuggets on Temporarily Offline's channel in the last couple of weeks. So this board does the M17 function, and through basically a serial connection, we can connect this board to a non-digital radio and use the radio in analog mode and have an M17 radio when I don't actually have an M17 radio. So the radio I have is this old guy. This is a ICOM 5061D, 5061D. And I don't know the exact, I don't think that's going to focus on that sticker. I'll take my word for it. It's a 5061D. And as you can see, this guy has a 25-pin serial port over here. And of course, our antenna connector, and I think that's an audio out right there. This radio originally it's a 2-meter rig. It also is NXDN. ICOM called that IDAS. Kenwood calls it NexEdge. Hams call it NXDN, all the same protocol. And I have used this radio with a hotspot running NXDN to play with the NXDN digital voice mode, I don't know, a couple, 3 years ago. And this radio has been in the box of forgotten radios for quite a while. And I dug it out because it should work with the board. And as a matter of fact, it will work with the board. It needs to do data, which it does, and it has a convenient connector. And so what we're going to do in this video is take the M17 module board here. We're going to flash it with the firmware for the board. That's our first step in this video. And then I've got to take a cable and build it. Now I have a 25-pin cable that I bought from Amazon. One end already has the DB25 male on it, and the other end is 25 tinned wire ends, conveniently labeled 1 through 25, and we need to fasten them to the board. Now, there's a couple ways we can do this. One way would be to buy a male DB9, or do you say DE9 connector, and we could use that with like a breakout connector. The other way is that the board itself is already got pins on it, and they don't really show up on this camera too well. So with a pin out from the ICOM side, I should be able to take the corresponding pins and solder them onto the board, and that will allow the radio to talk directly to the M17 board, which will then do the whole analog radio to networky things. That's the plan. Stick around and let's get at it. Okay, I've cleared the decks here, and what we need to do now is boot the device up into DFU mode so we can flash firmware on it. So to do that, we have to hold down the left button, and you'll see here these buttons are labeled. I don't know how well the labels show up on camera, but that is the left button. And so we're going to hold that and plug this guy in, and that puts him into DFU mode. And you can see that LED right up here. It's blue in real life. On the camera, it looks white as can be. So now he's in DFU mode. All right. Now, once he's in DFU mode, what we're going to do is jump over to this screen, and we're going to install firmware on this board. Now, I've already installed it, but what we need to do is we need to download the firmware, and I'm going to have links for these instructions and the firmware and all that in the video description below. So the instructions tell you need to install DFU utility, and you need to install libUSB, and it has those instructions, exactly what you need to do for Windows and Linux. We're using Linux here. It also tells you where to get the binary firmware file for OpenRTX. So what I did is I went to that web page and copied the link for the actual Module 17 binary file. And then once I have that address, I'm going to come over here and we're going to go, let me clear screen out. And we're going to go wget without the F in it, wget. And we're going to paste in that link. And we're going to download the Module 17 binary file. So now we've downloaded it. Now, it says .1 on the screen right up here. That's because I've already downloaded it. I didn't have the camera on. So we've got our file, and the next thing we want to do is we want to run our DFU utility, and we want to flash that WRTX file to the board, our WRTX, OpenRTX file, the binary firmware file, to our M17 module board. So DFU the instructions for this command are in the links that I have posted below. Very clear instructions from the GitHub. Absolutely can follow it step by step and do this. So we're going to do that. And it's going to tell us an error because we're in DFU mode, I guess. And then it's going to erase the firmware, reflash it. And this takes just a few seconds, maybe about 30 seconds. It's going to finish up. And when it's finished, it'll tell us it was successful. All right, now at that point, what we're going to do is switch cameras once again. And we're going to power the board off by unplugging it. And then we're going to plug the board back in, not in DFU mode. And if successful, we should have a screen that says OpenRTX like you saw, and then our device screen. Now, it saved my programming apparently to EEPROM. That didn't get wiped out in the firmware reflash, which is not what I expected. But you can see here menu, and then these buttons correlate to what's going on the screen. So we can hit that. We can go into settings. We can go into display. We can change the brightness on the display up or down. We can back out of a specific menu setting, scroll down to the next one. I've already put in my call sign. We're not going to fool with those at this point. We can look at some other settings here. Without having ever used Module 17, I don't know how relevant any of these settings are, so I'm not fooling with them at this point. And then we can go back and zap our board to default settings. We can just get out of that. We can come down here and look at info, and it tells us what version of firmware we have installed and hardware version, and this is Rev 0.1e. And then we can also take a look on the About page, and it will show us the names and call signs of the guys who are working on the code. And then, of course, we can shut the board down. So now we're good. I'm going to scroll down to shutdown, execute a shutdown. It tells me open RTX and reboots the board. Close enough for government work. So our next step with this board at this point is going to be to take our cable and wire up the cable. Okay, so the next step we have to do to convert this radio is going to be to do these things. So obviously we need to make a cable yet, and we're going to make the cable, but that'll probably be the last thing I do. The first thing, the next thing we need to do is what we're showing here. So we have to modify the radio, and there's some filtering in that we need to turn, some solder bridges we need to cut or join together. For whatever reason, ICOM calls those coffee grains. They're located at the edge of the board next to the FFC connector for the front panel. So we need to bridge D, cut K, and bridge L. So I've got to drop some solder on D and L, and I need to cut the solder bridge on K. All right, so now we have our radio set up here, and there's our M17 board. We're not ready for that yet. So let's get these things loose and see what we got. Find our coffee grains and do the D. Hopefully I won't drop any of these screws on the carpet. I think it ought to be a law that they make screws orange, or you can see them when you drop them. And now let's see if we can find our coffee grains. I don't know how well you can see it on the camera. Those look like screws, but they're very tiny little solder pads. And some of them are already connected through the trace. and some are not. So that's what we have to bridge or cut. We'll make those changes like we're seeing here. So we need to bridge D and L and cut K. Okay, soldering iron is heating up and apparently hot at this point. I never have done a video on this. This is a Nico soldering iron. This is USB, chargeable, and then completely battery operated. I don't know that this is great or terrible. I bought it, I played with it for like a couple minutes, and then I have a regular Weller station that just works every time. So I'm going to attempt this with the Nico. This is a nice little unit. It's USB-C chargeable, somewhere there. And then you basically just turn it on. There's no temperature adjustment, and it's supposed to get hot enough to do the deed. And it's certainly melting the flux and letting me clean the end of it off. So we ought to be good. So now we need to bridge D and L. And the question is, can I see D and L well enough to do this without a magnifying? There is D right over here. It's so small, and I really need my overhead magnifying glass to see this. It looks like that stayed on there. That's D. And then Mr. L is the soldering iron does come with this little stand. This is not a charging base or anything. This is just to stick a hot iron in, so you don't burn your non-soldering pad. Okay, so there's our solder bridges. We have bridged D and L, and now we need to cut K. Okay, off camera I did it because it's really hard to see. I used the Mark I pocket knife. And I've got the Kaiweets meter here in continuity mode, and we'll see if we have indeed broken Mr. K. So that little project is done there. The next step we're going to do now is we're going to build our cable. So we'll have to follow those instructions and go from there. All right, so after a little studying on pinouts, here's what we came up with. And I made this awesome chart that's so beautiful. So here is the ICOM DB25 cable with its corresponding pin to the DE9 and its corresponding pin. Now, a bonus on this with this particular setup is that pin 11 of that ICOM cable also is 12 volts DC. Pin 9 on our DE9 is 12 volts DC. So you can actually power the M17 board from the radio. So that's cool because that means I don't have to have an external power adapter to hook up the radio. Right now, I was using a Raspberry Pi USB-C power adapter, which works fine for what we're doing right now. But in the future, I can just hotwire the power button on the M17 module to on, bridge it, and then when I turn on the radio or the power supply that the radio is connected to and the radio comes on, it'll turn on the M17 board at the same time. So that's pretty cool, kind of a bonus feature with this setup. So this is audio in to the radio here, and that is baseband transmit on the DE9 side. This is audio out from the radio, and that goes to baseband receive on the DE9 side. And when I say DE9, if you're old like me, we called this a DB9 back in the day, but now it's apparently a DE9. Pin 14 goes to pin 8, that's ground. 19 goes to 5, that's our PTT line. And then 11 goes to 9, and that's our 12-volt power source. So I guess let's get putting the cable together. Now, what I decided to do, I was originally going to solder the pins off the cable, which are here, to the corresponding spot on the board. And that would absolutely work. But then I have this giant cable mess that I have to deal with across the board. And there is a 3D printable case for this that I'd like to put this in so I don't have a bare naked board sitting around. So I thought, well, let's do the 9-pin connector because it's already there. We have that. That's what this is designed for right there. So in my opinion, it's a whole lot easier to do this. Plus which, if for some reason I get one of these pins wrong, I can change it out without having to solder and unsolder stuff on this board. So Move that guy out of the way. Move Mr. Radio out of the way. And get to cabling. And I bought it for a couple reasons. Number one, I have some 25-pin cables laying around somewhere. Sure I do, in a box or a drawer. But I would have to cut one end off and then tone out every one of these pins to the wire, which means you have to strip the wire, put a meter on the pin, put a meter on the other end of the wire, and then make a little map of what they all are. Fortuitously, as you can see, these are all labeled with what they are. I thought was cool. Plus which, and I've done a video on these before, these have ferrules already installed on the ends of them. And when you're using this kind of connector, ferrule is what you want. Because now I don't have to worry about stripping back tiny wires, and I don't have to worry about the screw not making good contact in with the end of the wire. So these things will make real solid contact. So we have our map. What I need to do now is look at my numbers on the adapter, and you can see, not focusing super well on this, but you can see, there we go, that they are numbered on both sides, 1 through 5, 6, 7, 8, 9, and ground. There. So, and apparently there's 2 grounds on this, because according to our map, pin 8 is also ground. Those, yeah, 6, 7, 8, 9 that way, and then ground. So 8 and ground are apparently tied together. Okay, we've got all our wires hooked up now. These are in here good and tight. And we have the right wires on the right pins on the DE9 side. Now, this is a hot mess down here. And when I test this and this thing all works, I'm going to cut off all this extra wire and clean this up. So I may just end up putting a big old fat piece of shrink wrap on it today. Just something to protect the wires and kind of hold them in there a little better. I think we're ready to kick the tires and light the fires and see if we can fire up the M17 module off of our DE19 connector when it's hooked into our ICOM radio. I don't know if this is going to work. We may have smoke. All right, we've got everything hooked up, I think, probably. Now, one thing I did do, you'll notice here that there's tape all over that. That's the rest of those wires that we didn't use, and I don't want them kicking around loose. This is a hot wire. We're going to tape him up too, since we're not using him, because I don't want stuff touching stuff. So we're only using 5 wires on the guy, and then all the rest of these had connectors on. When I'm done, what's going to happen is all those extra wires, like I said, are going to get cut off. But for now, I don't want to do that until I'm sure that I have everything pinned correctly, assuming nothing, goes when I turn the power on. So our cable is connected. The M17 board is connected. I don't have power directly to the M17 board. It should come out of the radio right here on that pin. Have our antenna connected. And then if everything powers up and no smoke escapes, we'll flip over and take a look at my M17 hotspot and see if we can actually do the thing. So here we go. Here's power. And the radio came on. That should turn on our M17 board. That's awesome. Okay. Everything is on. Okay. That's a good sign. That's the hotspot IDing. So let's flip over to the hotspot screen and see what happens. All right. I'm excited. This should work. We should see something on M17 screen on the hotspot. And we should also see something here on the OpenRTX, the M17 module board. I don't have them both at the same time. So I'm going to key up. Let's see what happens. Whiskey Tango 1 Whiskey, testing 1, 2, 3, 4. Well, that's no point. Oh, it's time to do a little debugging. I know that the radio works because I can key it up on VHF call, for example, and hear myself talking just fine on another radio. That's not the problem. The radio does key and it does transmit and it does receive just fine. Somehow the interface between the ICOM 5061D and the OpenRTX board, which is behind my big head, So somehow the interfacing between the OpenRTX board and the ICOM radio is just not working right. And I'm out of airspeed and runway on this for the time being. Okay, we've got everything wired up now and it seems to be working. There was a couple of gotchas with this that are probably mentioned in the information about it. I hesitate to say instructions because it's a little bit of hit or miss on documentation for getting everything set up. With this particular radio, and this is the ICOM 5061, this is an NXDN / analog radio. You cannot use this mic. Doesn't work. You have to use an external K-style microphone. Now, there is some information that the OpenRTX boys, the M17 groups, and there's like 2 or 3 different groups involved in this, are working on actually a literal bolt-in replacement board for replacing the existing digital board in the 5061 and its brothers and sisters like the 6061, 5060, 6060, so on and so forth. So that would be very cool because then I don't have to have all of this. So it does work-ish. I had a little bit of tweaking I had to do, and this is probably the world's worst microphone for doing this. What's interesting, and I don't know exactly why, I had to set the bandwidth to narrow for the analog channel that the M17 board actually transmits on. Also, the bit error rate on it was quite high until I tweaked it. What's interesting is that when I was setting all this up, I wanted to validate that this radio was still good. So I set the hotspot for NXDN and reprogrammed the radio to add NXDN programming back into it, and it worked fine with no adjustments to the RX offset. Yet when I used the M17 board, I had to do some tweaking for the receive offset. Now, there may be a way to do that on a per protocol basis. I'm not 100% sure. As far as I know, it's a global setting. So there it is. So what I wanted to show you, and let me switch cameras now. So here is our M17 dashboard right here, and you can see where I was keying up. I've still got a few bugs in this, but I'm going to call it good for now. The basic concept is proven. When I key up, what you see is you see me key Whiskey Tango 1 Whiskey radio check 1 2 3. And you see me key up, and then immediately you see VK3JED, his call sign right after mine, and that happens every time I key. So I'm not entirely sure what that's about. If we pop over and look at the log on it, you'll see, and I feel that this is configuration in Pi-Star. I'm using Pi-Star for this at the moment. You can see when I keyed up down here, it said the mode was set to M17 right there. And then it received a transmission from me to everybody, and see that bit error rate is still kind of stupid. Received network voice transmission from WT1W, end of transmission. And then immediately thereafter, every time I get the VK3JED thing. Have no idea what that is. I can't really use this at the moment because this speaker mic is so terrible. You can't hardly hear. It's very, very terrible. And I feel that that's probably the speaker mic. So on the board, there is pads to put in a regular speaker. And if I figure out a case to mount all this stuff in, I will probably hardwire a regular speaker jack in there so I can plug in like a CB truck speaker or something where I can hear this. But that works. We're good. And the radio still does the NXDN thing. You can see there my horrible bit error rate. And yeah, 6.4%. Whiskey Tango 1 Whiskey, testing 1 2 3 4. So yeah, that is that's hideous bit error rate on that guy. We've got the thing done, but it does work. It's a way to get M17 without particularly buying an M17 radio. I'm very excited about the board that they're going to have for this. One of the guys in the M17 group demoed that on his YouTube channel, and I'll put a link to his YouTube channel in the description below. as well as links for this other stuff here. Guys, that is going to do it for this video. I think it went a little long, but I appreciate you sticking with me if you did. 73, y'all. Have a good day.